So it says, people in movies often jump from buildings into pools. If a person jumps horizontally from the 10th floor, which is 30 meters above the ground, to a pool that is 5 meters away from the building, with what initial speed must the person jump? No, I'm not going to send it to Classroom. I will upload in YouTube and I will send a PDF file to the group. Okay, that's what I'm going to do. So remember that I gave you the list of the formulas? I gave you the vertical and horizontal formulas, okay? From those formulas, those are not the definite formulas, okay? You can take these formulas and isolate for the unknowns. So the very first that I do with this kind of exercises is I like to sketch the problem, okay? I like to sketch the problem. So imagine that this is the building. Wait. I see. So imagine that this is a building and here there is like the pool, okay? Well, okay, there you go. So there is a stuntman, okay, that is going to do an action scene. And the idea of this scene is that this person must jump from the building to the pool, okay? So this person is located, imagine that this person is located right here, okay? Which that is the 10th floor. So the idea is that this person is gonna be running, horizontally running until this person can jump, okay? So this person is gonna bring a velocity in this direction and the distance that is between the building and the pool, it says that it is 5 meters. It says a pool that is 5 meters away from the building, okay? So this person needs to jump, okay? And when this person jumps, needs to have this trajectory, okay? Because if it's less than that, it's going to hurt, okay? Probably going to break down a leg or something. Nobody wants that, okay? I get that accidents happen, but that's something that nobody wants. So ideally, this person is gonna get in the pool. Now, this person, vertically, this person is located in the 10th floor, which is 30 meters from the ground. Okay, so okay, it says with one initial speed must the person jump. So I'm going to write my given. Okay, and I say the initial position of this person is in the building, okay? And this initial position, the vertical position, is located 30 meters from the ground, okay? So my first given is 30 meters from the ground, okay? 30 meters above ground. Now, what is going to be the final position of this person? Whether if the person gets into the pool or outside the pool, okay? The idea is that the final position will be at 0, okay? Right in the ground, at ground level, okay? It's gonna be the position, the vertical position 0, okay? So you want this person to jump to the pool. So the final position is going to be 0 meters. What can we do with these two information? We can get delta y. Delta y is final position minus initial vertical position. So we apply the formula and we say 0 minus 30 meters. So the change in the vertical position is negative 30 meters, just like we used to get it in free fall, okay? Now, how do we analyze this answer? We say that here, the person ends up in a lower position than that person was initially. So that's why we have a negative change in the vertical position, because the final position is located lower than the initial position. That's why we have the negative. Now, what else do we have? This distance that I have from between the pool and the building, is that a vertical distance or is that a horizontal distance?
Horizontal distance.
It's a horizontal distance, okay? So that's my other given. So that is my my delta x is gonna be 5 meters, okay? And now they're asking you with what initial speed must a person jump, okay? So you need to find BI, okay? So I gave you a list of formulas, okay? One of these formulas were for horizontal, for the horizontal trajectory, okay? So for the horizontal ones, I have this formula, okay? Initial velocity in x is equal to final velocity in x is equal to constant. That means that there's no change in the velocity, constant. And the other I gave you was that the velocity in x is equal to, no, which one? The other was delta x. Delta x is equal to velocity in x multiplying the time. I think that was the formula that I gave you, okay? And then I gave you the other list of formulas for vertical projectile motion. Did I give you another one for horizontal? I think I didn't. I think there were the only two. For vertical, I gave you final velocity in y. I gave you 2 of final velocity in y and 1 for delta y. Okay. Remember the second one was 2 times gravity, delta t. I remember delta y was 0.5 gravity, delta t square. And I forgot the first one. So I'm gonna check the picture that I took from the whiteboard. Though I know that I'm not gonna use it, most likely, okay? I know that I'm not gonna use it, but I have to write it. Gravity time, sorry. The easy one is the one that I forgot, imagine. Okay, so as you see, I didn't give you formulas for time. No, I didn't give you any formula for time, but we can isolate time according to what the information that we have. Okay, so according to the information I have, I get delta y, I get delta x, okay? And of course, there is always an implicit given Even if it's not written there in the word problem, the other implicit given is gravity, okay? So even if gravity is not written in the problem, gravity is always there, part of the given. So basically, my givens are delta y, gravity, and delta x. From all the formulas that I have, which ones I can use? According to what I have. Do I have delta x?
Yes.
Do I have velocity in x? I don't have it, okay? And I don't have time. So this one, I cannot use it. Now let's see the formulas that I have over there. I don't have velocity in y. I have gravity, but I don't have the time. So I cannot use this formula, okay? For final velocity in y, I don't have final velocity in y. 2 is a constant. I have gravity, but I don't have the time. So I cannot use the second one either. About the third formula, I do have delta y. 0.5 is a constant. I have gravity, and I don't have the time. But I can isolate for the time. So this is what I'm going to do, okay? You see me now that just with the original formulas, I didn't know which formula to use. But just by the analysis of knowing what am I given, I know now that I have to use only the last formula, okay? Because this one, I just have one unknown. In the last formula, I just have one unknown. So here's the thing. So we say solution of or process of solution. Okay. So in the first step, I will isolate for the time. Which in this case, the unknown is the time, okay? So I have this formula. My dog's having nightmares. So cute. Wait. Sorry, guys. My dog was having nightmares. I don't like to listen to him like that. It's very painful. Anyway, 0.5, we make substitution. No, we don't make substitution of the given. We need to isolate for delta t, okay? So delta t, as you can see, is raised to the second power, which means that it's most likely. I already said what are the topics that are coming on Monday. Guys, what is the topic that I will be evaluating on Monday?
Adding vectors? Or
Just adding vectors. This topic is not coming on Monday, but I'm not gonna give a review of vectors because I already took my time to explain vectors step by step. This topic is not coming in Monday's quiz. Okay? So the topic that is coming is just vectors. You need to be more interested in the class, my friend, so you can actually know what topics are coming. Thank you, Efrain, by the way. Poor Efrain, by the way. I had to mention these people. They don't love you, Efrain. They don't love you, okay? They're not good friends. I need to actually dare to tea, okay? No, I can't focus now. Now, if we need to isolate for delta t, okay, the first thing that I have to do is I need to move these two terms that they are multiplying delta t. They're going to go to the other side to divide. They are multiplying and they come to this side by performing a division. So my equation is now delta y divided by 0.5 gravity. All this is equal to delta t squared. To get rid of the square, I apply square root in both sides of the equation. Okay? So this square root is going to cancel out with the power of 2 at the time. So from this, we get this isolation. Delta t is equal to the square root of delta y divided by 0.5 gravity. Okay? Now, you can write the expression like this or to the other side if you prefer. Delta t equals delta y divided by 0.5 g. And now just we can find delta t. So delta t is equal to the square root of delta y. According to the data that we got in this exercise, delta y is this one over here, negative 30 meters. We already got it, okay? We already got it when we were writing the givens. So these are negative 30 meters divided by 0.5 of the gravity. Sorry. Remember that gravity is negative 9.81 meters per second squared. It is important that here you don't mess it up with the units and neither with the signs, okay? That's why we get delta y and we analyze correctly the position of the object or of the person. Final position is lower than the initial position, so delta y is negative. In your procedure, if I see that your delta y is positive and magically your answer appears, it's incorrect, my friend. Because if you perform this in your calculator, it's gonna give you a math or a syntax error, okay? So it's not the same. Be careful with the signs. So how are you going to do this in your calculator? You're going to, first, you're going to make the division, okay? Negative 30 divided by 0.5 divided by negative 9.81. How much did you get?
6.11.
6.12 rounded, but it's okay, 6.11. These are seconds squared, okay? Seconds squared, because these meters and meters were canceled, okay? And now all we need to do is apply the square root. Square root of your answer equal. How much is delta t?
2.47.
2.47. And now, this is like having square root of, say, 6.11 times square root of second square, okay? So the final unit will be just seconds, okay? Just seconds, the one that you didn't cancel. So with this, we are able to find the time. But that's not what the problem is asking us to find, okay? The problem is asking us to find initial velocity, okay? So it says initial velocity in x is equal to final velocity in x is constant. And I also have this equation that has velocity in x, okay? And if you notice here, there are no formulas for initial velocity in y, in the vertical position, because in projectile motion launched horizontally, initially the object or the person is coming just horizontally. So it doesn't exist the initial velocity in the y-axis, just x-axis. So now that we have delta t, we're gonna be using this formula to isolate for the velocity. Okay? So now it's time for the second step. Find the initial speed. And just remember, initial speed in the initial horizontal speed is equal to the final horizontal speed, okay? So you're going to find any horizontal velocity. To do that, we're gonna take the equation that involves horizontal velocity, which is this one, delta x equals velocity in x times delta t, and we're going to isolate bx. So delta t is multiplying bx. When you isolate, you will send it to the other side of the equation to perform a division. So now you will have delta x divided by delta t equals bx. Or you can just rewrite the expression as bx equals delta x over t. Now all we need to do is we need to isolate delta x, that is, let's see the given. Delta x is 5 meters, okay? And delta t is the one that we just got. That is 2.47 seconds. How much is bx?
2.02 meters per second.
2.02. And the units are going to be meters above and seconds below. So it's going to be meters per second. And with this is it. So as I was telling you the other day, this is like the easy topic. From this exercise, do you have a doubt? Just remember to be careful while you write the givens. I think you don't pay too much attention to this step, but this step is key. When you calculate delta y, when you analyze the position of the person, this part of the process is key. Because as I told you, imagine that here, because you read that the 34 is 30 meters, imagine that you, by mistake, you don't do this, and instead you just say that delta y is 30 meters. If you make this mistake, that is gonna give you a math error in the procedure. And during a quiz, when you have a math, you can deal with a math error in a homework or in a classwork, you can ask me and I can help you. But during a quiz, you start to freak out when you see I'm at error and you like you get instantly blocked. Okay, so try to not commit these mistakes. Remember, analyze the position of the object. Do you have a doubt on this exercise? It's very similar to free fall. It's very easy. Okay, free fall and this one are very easy and pretty much similar. The difference is that in free fall, they're not the same topic, even though they look like they're not the same topic. In free fall, you don't have this part because you don't have velocity in the horizontal position. In free fall, the object is just moving vertically. And in here is the object is moving horizontally and then begins to fall down, but still using the two directions. Now the other thing, I'm just going to show this, okay? Wait. Just the two list of formulas that I gave you, those are the formulas that you are going to use. Now, I like to use this app. Well, it's not an app, it's a website. Okay, this website allows me to show you the projectile motion. This what you see here, of course, it is the well, that's my target. Okay, so if you want, I can share with you the this link so you can be testing. But once I teach you the other topic, okay, I just want to show you that the other type of projectile motion is the one that is at an angle. And as you can see here, I have an angle, okay? It's well, I don't know the name. It's just saved in my favorite websites, but I can share you the link, okay? So this is going to show you how these projectiles are moving throughout the entire trajectory. Okay, I can move the angle, and you can see. Oh, I hit the target. Look, I'm cool. I hit the target. Yay! Well, I wasn't trying. I mean, I was just showing you, but in the end, I kind of did it. You can show even in at a slow motion. I can increase actually the velocity. Look, by increasing the velocity, even if my target is, it was too much, too fast. But anyway, you can see the three trajectories that I show, the three of them show that curved path that is known, as I told you the other day, a parabola. We're going to continue this class this week, okay? Anyway, bye guys, enjoy your weekend.
See you, Miss.
Bye, good afternoon.
Good afternoon.
Bye, Miss.
Bye.
Cute earrings, by the way.
Ah!